like to begin by giving a short introduction to our topic, disruptive solar technologies. And I have prepared a slide set, which I hope I can share with you. Yes. Okay, excellent. So the issue we are talking about is solar technologies. And the first slide I would like to share with you is a slide which shows a quite unexpected result. If we go back to 1992, and we had a total installation of 100 megawatt at this time, and we compare it with today's situation, we see that we have an enormous, annual compounded growth rate of unbelievable 38%. You can easily calculate it yourself. If you plug in the numbers, 0.1 gigawatts 1992, 627 gigawatts 2019. So 38 gigawatt annually, our industry was growing. If we continue this type of growth, we will be 2030 at a total installation of several terawatt. And we will have a market which can exceed 1 terawatt of annual installations. And I think this is what we are heading into. This is what we should be aware of. And if we look at the distribution of annual additions of renewable power capacity, we see since about 2015, solar energy has taken over, and now from the more than 200 gigawatts of installed renewable power 2019, solar PV is by far the largest fraction, because you can install solar almost anywhere, whereas all the other technologies have geographical limitations. A very important point, if we look at solar technologies, is from where do they come? And we see that the situation has changed drastically since about 2008, at the time when the Chinese government had a very wise decision to say photovoltaics, the harvest of solar energy, is of key strategic importance for the People's Republic of China. And you see the positive result of this now. Almost 90% of all PV modules are coming out of China. I think this is a success story, but this is as well a story which gives us a little bit concern. I will come back to this later, but we want to talk about technologies. And I like to use a very old slide from Ralph Prof from Fraunhofer ISE from 2009, who shows the development of PV technologies. And the key message out of this chart is crystalline silicon PV, which is a dominant PV technology, is not a commodity, but still a very rapidly developing high-tech product. You know, we had the industry standard technology. In the last 5 years, we saw the evolvement of PERC technology, and now we are heading into the range of several competing high efficiency technologies. And I want to talk about this in a little bit more detail. You know, you see on this slide as well, which is from Fraunhofer ISE. On the left top, you see the concept of the PERC technology, where you passivate the backside and you have contacts placed by lasers so that only a few points have a metal semiconductor contact. On the right-hand side, on the top, you see the heterojunction approach. The heterojunction approach has 2 layers of amorphous silicon on both sides of a crystalline silicon wafer. So this technology is, from its design, very good for bifacial technology, but of course with PERC and others you can as well achieve bifaciality. But this is really showing that technology is rapidly developing. A very interesting technology which was developed at Fraunhofer ISE when I was director is the oxide contact, which is transparent and which is allowing to make both passivation and contacting, because if you make a oxide layer thin, you have the quantum mechanical tunnel effect, and carriers can tunnel through the layers, and you see that we can achieve very high efficiencies, very close to the world record, which is about 27% based on a heterojunction technology. So these are the examples of breakthrough technologies. But let us now talk about efficiencies. When we have the old industry standard technology, which is almost still today about 40% of the world's production. This has an efficiency limit in the order of 20%. And I would like to thank Andreas Bett, who is one of the new institute directors of Fraunhofer ISE. He has prepared this very nice slides. PERC technology, where you have the passivated backside, you avoid carrier recombination on the backside, and on the right-hand side you see again a cross-section through PERC, is now leveling off at efficiencies of about 24%. It's already quite a substantial step from standard technology, and it has the advantage that it is quite easy to convert existing production lines to this new technology, but it is limited. Now we come into the range of the passivating contacts, like heterojunction technologies or like the TOPCon, which I showed, and there we will go even higher to 26%. And the question is, what comes after this? After this, we are hitting the glass ceiling of silicon technology, which is about 29%. And if we want to go beyond this, we must go into new concepts, and the new concept will probably be the tandem concepts, where we have semiconductors with different band gap on top of each other. This can be a perovskite layer, this can be a 3-5 layer on top of silicon, and with this we have the possibility to increase to 29, 30 and higher percentages depending on the design of the cell. The key issue is, of course, to realize such a technology in a cost-efficient way. And in the last talk of today's session, we will hear more about this. Of course, there are many innovative approaches all along the whole value chain. I did not talk about materials, I did not talk about wafers, but we will hear the presentation of Stefan Weber from NextWave about innovative wafer technologies. I talked about PV technologies, but now I should as well talk about the system integration, because photovoltaics needs land and needs area. And of course, area is scarce in many parts of the world. Not always. We have lots of deserts and so on, which we can cover by PV. But of course, it is very innovative to go on water areas. We cannot go into the open ocean because the panels usually don't withstand waves, but we can go to all enclosed inland lakes. And this is, of course, very exciting. You see a very beautiful examples, which I got from Stefan Schindele, who was at the time at Fraunhofer ISE, of floating PV installations. Another new way to install PV is to share PV with agriculture. As a matter of fact, climate change will lead to higher solar irradiance, and there are quite a few plants who are happy to have partial shading provided by PV. This PV can be installed in different ways depending on how much shading you want to have, but the key message is we can share the same area for photovoltaics and for agricultural use, and therefore we really virtually have no limit in how much PV penetration can proceed worldwide. Europe has a very special place in this value chain because in Europe we have a big market. Of course, we are still lacking key components of the photovoltaic value chain. Most important, we are lacking the PV cells. We have the R&D, we have the materials, we have the wafers, we have as well module manufacturing, but we do not have at present large scale and large volume cell manufacturing. And this is something the European Solar Manufacturing Council, where that I chair together with Gaëtan Masson, who chaired the previous session in this fantastic conference. We are working on it to encourage companies and to convince politicians how important it is to establish a domestic photovoltaic industry. And the same holds for India, the same holds for the United States, for many countries in the world. This is the way we have to go. So I would like to finish my short introduction. The rapidly growing solar market shows disruptive innovations all along the whole value chain, as I discussed before. The core, of course, for photovoltaics is a cell technology, because there is a place where light is converted into electricity. we are experiencing the transition from the second generation PERC technology to the third generation with high efficiency technologies based on passivating contacts. And then the fourth technology, fourth generation, will be tandem cells, for which we still have several options open. A key question will be how quickly PV production will extend to go outside China to Europe, the US, Japan, and India. Today, we are at a very, very critical geopolitical situation. Talking from the point of view of Europe, we have problems with China, we have problems with the United States, we have problems with Russia. So the connection Europe, Japan, India stays outside these problematic relations, and therefore I think we have very exciting opportunities to work together in the future. This decade will be decisive because climate scientists show us that if we cannot manage to drastically reduce our CO2 emissions by 2030, we lose our last chance to seriously combat climate change. So this decade, the decade from 1920 to 1930, will be a decisive decade in which we need to push quickly large-scale deployment of renewable energy, introduction of green hydrogen based on renewable electricity, decarbonization of the whole economy, decarbonization of transportation. These tasks are waiting for us, and our contribution to this task will be the rapid decarbonization of the energy sector by the transformation to renewable energies. With this, I would like to thank you so much. We will experience, I hope, a European solar industry renaissance, and I'm looking forward to experience the same in India. Actually, from Europe, we are ready to grant our hand to India and to all our other countries that want to collaborate with us. Thank you so very much, and thank you for the attention.